Solving polynomial inequalities is quite a bit like solving polynomial equations, to be expected because they're just basically the same type. There are a few things that we need to watch out for is how do we know what regions are our solutions and whatnot. With polynomial equations, we get just distinct solutions. So before we even get started, this one is going to be one that's easier just to go ahead and take a look at our steps. Step one, change it to an equation. Now this seems kind of weird because we're solving polynomial inequalities. Why would we change it to an equation? Well, we know how to solve polynomial equations, and then we're just going to adapt our answer to the inequality. So step two is going to be solve. Put these values on a number line. Open or closed circles depending on the inequality. All right, step three, we're going to pick test values from each region and plug them into the original inequality. Step four, we're going to say shade the true regions and use interval notation. Okay, let me read through them again for you. We're going to change this thing to an inequality again because we know how to solve an inequality. We're going to solve that, we're going to change to an equation because we know how to solve an equation. We're going to solve that. We're going to put those values on a number line, open or close circles depending on the original inequality. And then we're going to pick test values from each region. You'll see what I mean by region when we do that and plug it in the original inequality. This is us determining which regions are true for the inequality part. And then all we got to do is shade the true regions and use interval notation. So let's say that, let's start out with, again, our directions here might just be solve or solve, graph, use interval notation. Let's see if we got an easy one too. X squared, I don't know, plus x minus 6 is, let's go less than or equal to 0. Okay, in this case, this is a polynomial inequality. More specifically, we would say that this is a quadratic inequality. Let's go ahead and change this to an equal sign because we know how to solve a quadratic. Go through all your steps for solving quadratics here. We cannot extract the root, but this will factor. This factors to x plus 3, x minus 2 is equal to 0. Two things multiplied together equaling 0. One of those factors has to be a 0. So we set each factor equal to 0 and solve. All right, I went through that part kind of quick because hopefully you've been practicing these and it's going a lot quicker for you. All right, that's the equation part. But remember, this is not an equation, this is an inequality. So what we need to do now is take yourself a number line. Let's see, just put the values on there that we're concerned with, -3 and 2. Those are the solutions to our equation. Now, these going to get open circles or closed circles? Well, our original inequality has the equal sign, so these do get a closed circle. Now notice that those two values break apart the number line into 3 different regions. So we need to figure out which one of these regions where are our solutions. Our solutions can be here, here, or here, combinations of them. So what we're going to do is we're going to pick a test value from each region. So any number over here, let's say -4, any number between them, 0 is always fun to pick, and say 3. So for each one of these, you need to do a bunch of arithmetic. We're going to take each one of those numbers, plug it in the original inequality, and see if it is true or false. So for the first one, if I plug -4 into the original inequality, make sure you use parentheses, I want to know is that less than or equal to 0. Well, that's going to be 16 minus 4 minus 6. Well, what's that? That's 12 minus, that's a 0. 12 minus 6 less than 0. 6 is less than 0. That is not true. That is false. So over here, I'm going to put just an F, just so I know that I know I don't have any answers over there. Then we pick another number, so in between we pick 0, so this one's going to be easy. 0 squared plus 0 minus 6 is less than there. So negative 6 is less than 0, so this region here is true. And for our last one, let's go ahead and test it. If I plug 3 in there, 3 squared plus 3 minus 6, is that less than or equal to 0? 9 plus 3 minus 6, less than or equal to 0. So that's 6 less than or equal to 0. Again, this is false. Okay, so you can see our only region that is true is right here in the middle. So that's where we're going to shade. And interval notation for this would be negative 3 to 2, and we're including both of them. All right, another way that you can kind of visualize this, if you have drawn pictures of polynomials before, or graph polynomials, we know that this is a parabola, and since the leading coefficient is positive, it's facing up. Now, here, remember, this axis is technically just for x's. I know we didn't write it on there, but that's just the x-axis. And we don't have a y-axis in here at all. But if there were a y-axis, it would be vertical like this. And think about this, when we take an equation and set it equal to 0 and solve, what we're finding is the x-intercepts. Now, you really don't need to do this, but you can kind of tie it together a few pieces here. Think about a parabola facing up, coming through these 2 points would look something like that. Now remember, our parabola, this is our parabola, so the equation that we're looking at, I'll put it right here, is y is equal to x squared plus x minus 6. So we want to know when those values, when those y's are less than 0. Or less than 0 means below the x-axis. And notice the parabola drops below the x-axis between negative 3 and 2. So if you're really good at graphing polynomials, you can kind of see how the number line relates to what the original picture of the polynomial is. However, if you didn't follow anything I just said there with the picture, don't worry about it. The steps here will solve every single one of these for you. Put the values that you got from solving the equation on the number line, pick values from the test region, plug it into the inequality, shade the true regions, and use interval notation. All right, let's take a look at just a couple more examples of this, because again, as long as you can solve polynomial equations, these are pretty straightforward. So let's put this out of here. All right, let's say we have, let's do x squared plus x minus 3, and let's just do less than 0. All right, again, we want to say that this is a polynomial inequality. More specifically, it's a quadratic inequality. So we're going to change this to an equal sign and solve. Well, solving our quadratic, the first thing we want to do is try to extract the root. We can't do that. Next thing we want to do is factor. That won't factor, so we're stuck with the quadratic formula. So just for practice, do me a favor, hit pause on the video and stick that into the quadratic formula and then come back. All right, let's see how you did. So for our quadratic formula, here our a is 1, b is 1, c is negative 3, and we know our quadratic formula is negative b square root minus 4ac, all divided by 2 times a. So this can be negative parentheses squared minus 4 parentheses 2 parentheses. So a is 1, b is 1, and c is negative 3. All right, let's see if we can simplify this. So this is going to be negative 1 plus or minus the square root of 1 plus 12 all over 2. Or x is negative 1 plus or minus the square root of 13 all over 2. All right, so we have two values. We need to put those on the number line, so we'll make them over here. Remember, we have a plus and a minus. So we have negative 1 plus the square root of 13 over 2. That'll be bigger. Negative 1 plus the square root of 13 over 2. And negative 1 minus the square root of 13 over 2. Now with our original inequality, that does not have the equal sign, so those are open circles. All right, now we need to pick values for each one of these regions and plug it into our inequality and see if it's true or false. Now, here's a problem. What is this number, right? That is a number, and if I had a calculator, I could stick it in the calculator, but we should be able to approximate that really, really fast in our head. Now, there's a video up how to approximate radicals. So remember here, if we're trying to do the square root of 13, the perfect square under 13 would be 9. Above it would be 16, which means if you take the square root of all those, I know that it has to fall between 3 and 4. Now we could get a little bit more precise, but let's just say 3.5 as a guess. See, all I need to know is what is this about? So what is -1 minus 3.5 all over 2? That's -4.5 over 2. So half of 4.5 is about -2 1/4-ish. Now again, all I need is to get kind of close here. So what would be a number over this way? Well, -3 would probably work. But remember, since we're approximating, it may be a good idea to get a little bit farther away. So instead of -3, again, which would most likely work, let's do -4. All right, what number is this? Well, same idea. What's -1 plus 3.5 all over 2? Well, that's 2.5 over 2. So half of 2.5 is 1.25. So, well, this one's definitely negative, that one's definitely positive, so I do know that 0 falls in between those two. And something bigger than 1.25, again, 2 would work, but let's be safe and move a little bit farther away and call it 3. All right, now the good news is now we really don't have to deal with that horrible square root thing anymore. We just had to approximate it. So now what do we do with each one of these? We take each one of those red values and plug it in the original inequality and determine whether or not it's true or false. So take -4, plug it in here, put 0 in here, and then put 3 in there and see if it's true or false. Now for time's sake, I'm going to go ahead and do this. If you plug -4 in there, you're going to get a false statement. If you plug 0 in there, you get a true statement. And if you plug 3 in there, you're going to get a false statement. So you can see the true region falls between those two numbers. So where did we shade? Well, we started shading in -1 minus the square root of 13 over 2. Stop shading in -1 plus the square root of 13 over 2. And we do not include either one of those. All right, I know the numbers got ugly, but all we had to do really to work with them is just get an approximation for them so we could pick numbers around them. Other than that, it's easy. We're just plugging back into our original inequality. All right, let's take a look at maybe one more here. All right, let's make it maybe a little bit harder. Let's do x cubed minus 5x squared minus 4x plus 20. Let's do greater than or equal to 0. Okay. Again, we want to classify it before we do anything. This is a polynomial inequality, so what we want to do is change this to an equation and try to solve. So I get x cubed minus 5x squared minus 4x plus 20 equals 0. Well, this is a polynomial equation. To solve polynomial equations, the only method that we have so far is to move everything to one side and try to factor. Since we have 4 terms on this side, we're going to try to factor by grouping. So let's see if that works out. Out of the first pair, if I take out the greatest common factor, which is an x squared, I'm left with x minus 5. Minus, which means whatever I factor out of the second pair is going to be negative. I see those have a 4 in common. So if I factor a -4 out of both of those pieces, I have an x minus 5. I now have 2 terms. Both of these have a greatest common factor. They both have an x minus 5. From the first term, if I take out the x minus 5, I have an x squared. Minus from the second term, I'd have a 4. And we can factor a little bit more. That's x minus 5. That's the difference of squares. That factors x plus 2, x minus 2. All right, here we have 3 things multiplied together and equaling 0. So one of those factors has to be a 0. Plus 2 is equal to 0. X minus 2 is equal to 0. So solving each one of these, we get x is equal to 5, x equals -2, and x is equal to positive 2. All right, so we solved the polynomial equation, but this is an inequality, so we need the number line to help us decide where to shade. So you take each one of these values, let's say it goes from -2, +2, and 5. We put all those values on the number line. Now, do these get open or closed circles? The original inequality has the equal sign, so these get closed circles. I'll color them in. All right, that breaks our number line up into, this case, 4 different regions. So pick a number from each region. Pick a number over here on the left. Let's go -3. Always find a 0 because that's easy to use. How about 3 and 6? All right, from here, you got a lot of side work to do. And I'm going to let you do the side work on yourself to make sure that you can actually follow it. You're going to have to take each one of these red numbers individually and plug it into this inequality to see if it is true or false. When you do that, you should end up with false, true, true. All right, so I skipped a lot of side work there, so you're going to want to go back and make sure that you can actually fill that in. So let's see, where did we say that it should be shaded? Let's see, there's a true region, and over here's a true region. So for interval notation, let's see, we got this region shaded, -2 to 2. We're including both of those. And then we're shaded from 5 all the way out to infinity. We're including the 5, not including the infinity. Now, since we have 2 groups that contain our answers, we want to join these together, and we generally put the capital U symbol in there. Now, throughout your homework tonight, you may notice a pattern. A lot, not all of them, but a lot of these polynomial equations, the regions alternate from true, false, true, false. They don't have to, but they do alternate quite a bit. They alternate enough to where if you have a region that goes like true, true, you may want to check because there's a good chance that you actually made a mistake. You may not have because it absolutely can go true, true, but like I said, most of the time it alternates, so kind of keep an eye out for that. So solving polynomial inequalities. Change it to an equation, solve, put those values on a number line with either open or closed circles depending on the inequality, pick a test value, plug it in the original inequality, shade where it's true, use interval notation.